asteroid, Dr. Don Parker. He's going to give us a talk about the Mars.
Yeah, tell me about Mars. Okay, I was going to talk about physical fitness through proper diet and exercise, but lead you all in Tai Chi exercises, but we can't do that because they said, oh, Mars is coming, we want to talk about Mars. Okay. So anyway, Mars at the Winter Star Party, and Mars is the god of war. My 15-year-old granddaughter drew that for me last week and sent it over to me, and so I thought I'd show it. She's very talented. The kid has always had a great interest in science, even from an early age. And I'm really happy she takes after her grandpa, which is very good. So, anyway, but is Mars the god of war? She's got a spear and a shield, which is why we have this, the astrological symbol for Mars. We use this all in our correspondence and so on. It's the shield and the spear. Of course, today, some people consider this a bit threatening, so we'd have a new politically correct Mars. All right. Anyway, opposition is when Mars and the Sun and the Earth or any planet, they all line up. And opposition is coming in, just a week or so. So that's why we're talking about Mars now, because this is a great opportunity to observe it. March 3rd, 2012 is opposition. And there's the Earth zipping around. There's no epileptics here, are there? Okay, good. Mars is zipping, Earth catches up with it, and they line up at opposition date. And this occurs about every 26 months. So if we're going to say, next time Mars comes in opposition, this is the end of February, so it'll be sometime in April in 2014. So you can be really smart without having to look things up and figure things out. About every 26 months, we have oppositions. But not all oppositions are created equal, because the orbit of Mars is extremely elliptical. And we have points where, called perihelion, where Mars and the Earth are very close, and aphelion, where Mars is at the farthest point of its orbit, and that's not such a hot opposition as we have this year. So, for instance, in 2003, we had Mars, the closest it's been in 75,000 years. You remember that? And it's still on the internet that every year Mars comes around, it's the size of the full moon. And so that was 35 million miles away. In 2005, it was still kind of perihelic. It was pretty good, 44 million miles. Intermediate apparition in 2007. 2010, not so much. And this year, really not so much. It's about as far as it'll get from the Earth at opposition. But the good news, of course, is way high in the north sky for us Northern Hemisphere observers, so that we don't. And for you guys in the Netherlands, it's really, it's very good, yes. It's not skimming the horizon like most. They take amazing images because most of the planets, in the Netherlands are just along the horizon. So it's, I gotta hand it to them. Don't have it easy like we do here. So this cycle of oppositions repeats about every 15 to 17 years. And there'll be a quiz on this picture later. Here we are in 2012, aphelic. And in 2014, it's going to be better. And look at here, in 2018, it's going to be over 24 arc seconds. So it'll be really good. And all you got to do is stay alive until 2018, which in my case is really problematic. So, but anyway, I have to have a cigarette here in a minute. Okay. This kind of, why are they laughing? This is not a joke. All right. Shit. Anyway, this I made this slide years ago to show the relative sizes of Mars between aphelion and perihelion. These are actually to scale. And that's 1988, which was really, really good apparition. 1982, which was kind of like the one we got now. But you notice that's film, okay? And we move on to the next decades and we have CCD technology. And this is 2003, the closest it's been in 75,000 years. And this is 1995, which again, was the old Lynx camera. And we fast forward to today, and you get the webcam technology, which is amazing. So almost every, time Mars comes around, there's new technology, and your pictures keep getting better and better. And not only that, but you can do more and more quantitative work with them. So it's kind of neat. And you notice there's a difference here. When the Mars is at perihelic oppositions, you're seeing this side, which is the south. You see the south polar cap. At aphelion, you're seeing the north polar cap. In other words, Mars is tilted. It has seasons very much like the Earth. Its axis is tilted 25.2 degrees right now. And that does change because Mars doesn't have any massive moon, so it kind of skewers all over the place. But right now, the North Star on Mars is Deneb, and it has polar ice caps, which whack and wane very much like the Earth. It's just a schematic of Mars's axial tilt, and has a much neater pole star than the Earth, but other than that, it's not a good place to live. Okay, opposition is on March 3rd, 13.9 arc seconds, and you all know with an arc second, it's a pencil held up, the width of a pencil at the distance of a mile. So it's small. And March 5th is the closest approach because of the ellipticity of the orbit. Close approach doesn't line up with opposition exactly. And since Mars has seasons, we're going to be looking at late northern spring. And through this talk, I'll be talking about Mars dates. Mars date will be June 9th at opposition. Okay, now it's late northern spring. It will be in a couple of weeks here on Mars. What is the season on Earth at that time? March 3rd, it's late northern winter, right? Okay, this is a cocktail party thing here. You can tell your wife or your girlfriend, you really want to impress them. Just out of the blue, when the conversation lags, you say, did you know that at opposition, Mars will be ahead one season ahead of the Earth? And it generally clears the area fast, you know. Sort of like that dinner we had last night, Manny, when you started telling jokes and it cleared the restaurant. You know, it was amazing. But anyway, you're always looking one season ahead. So April 2014, that'll be early spring in the northern hemisphere on Earth, and it'll be late summer on Mars. See, northern hemisphere. Isn't that exciting? Aren't you glad you came? Okay, I do have to talk about image orientation because I show images south up, like you see in a real telescope, which is a Newtonian, a Dobsonian, or a Schmidt-Castle refractor without the star diagonal, looking straight through. So south is up, north is at the bottom, east and west. East is on the left, but that's Mars's east. So when you're talking about a planetary body and you're talking about its east, or at the east, generally you're referring to not the east in the sky, but the east on that body. It's a little hard to figure out at first, but you can figure that out because when you're shaking hands with somebody, their right hand is on your left, right? Correct? Okay. So when you're looking at planets, they all rotate toward their east, and that's kind of the way Mars rotates. I shouldn't have brought this up. So, to avoid all this incredible confusion, we no longer refer to it as east or west. We refer to it as an evening limb or a morning limb because the planet rotates toward its evening limb. And to further avoid confusion, we do another trick. There's Mars rotating, yay. And we say, okay, forget the evening, morning, preceding and following. This means when you trip over the cord that runs your telescope, that runs the drive, the planet will go in that direction, which is the preceding area. So we have north, south, preceding, following, or PF. And it's really important if you're doing a planet like Uranus, which is on its side anyway, it's flipped over, you kind of important to put those directions on your images. Yes, sir?
No, I said power failure.
Power failure, yes, exactly. Okay, you notice this is one of my images, and I always put that little PF in there. People say, what's that for? That shows the direction. Now I position it so because these people who get the images like to measure things precisely, I think to an obsessive extent, but I try to line it so north and south on Mars are lined up vertical, and then of course the preceding and following have to be flipped or rotated the same amount. And the way I make that is I just do turn on the AVI, the camera. I turn on the camera, and I just slew Mars back and forth across the image until I get an AVI file with a big long streak in it. And the way I make the streak is I go onto Registax and I say make a dark frame, and it just piles them all together, and I get this, and I go into Photoshop and figure out the direction and all that, and just so I have a sense of direction. With Mars, it's very important, particularly when you're using ultraviolet, violet filters, where surface features are not readily apparent. And again, for planets like Uranus, Neptune, where there's virtually nothing on them anyway, and who really cares? But you do it, to be nice. Okay, so anyway, we're back now here again, south, north, normal orientation for a Newtonian or a Dobbs or whatever, east, preceding limb, following limb. Okay, if you go to a refractor or a Schmidt-Castle with a star diagonal, which many of you will be using tonight, north will be at the top. A very famous editor of a magazine which will go unmentioned, they started putting their images with north at the top, the amateur images, because that's the way amateurs see them through their telescopes. Well, not true, because it puts north at the top, you use a star diagonal, also flips it east and west. So I look at this image of Mars, and I've been looking at it for 55 years, totally confusing to me. Because north is up, I can handle, but when you reverse east and west, so now you got this thing. So, but again, that's what it'll look like tonight. This is probably the presentation we'll have tonight. And, but you just have to remember, again, you want to orient yourself, just shut the drive off or slow it down for a minute and see which way the preceding limb is, and that's the evening side of Mars. Okay, now the other kind of telescope, of course, those of you who have Meade telescopes, there's a little different orientation. Okay. All righty. Sorry about that. Anyway, I hope this is the talk that I put in your computer, because if it isn't, I'm in trouble, but whatever. Okay, the Mars's day, it's Earth-like. It's a little over 24 hours long. It's a little bit slower rotating than the Earth, and that means it goes around only about 350 degrees in 24 hours. So it sort of backs up 10 degrees each day. So if you want to know what you're going to see tomorrow on Mars, you just back the thing up 10 degrees and you can get an idea like this, Monday, Tuesday, Wednesday. This would be observing Mars at the same time each night. And what you get is it takes 36 days to get back to the original longitude. So this is why we need observers placed around the world, because it's very nice to have somebody in Japan who's observing the side of Mars we won't be able to see for several weeks, and we do indeed have observers stationed around the world. That plus the internet really gives us almost real-time 24-hour coverage of Mars, Jupiter, and the planets. As an example, this is Freddie Willems, who lives in Hawaii, and he's a very avid planetary observer, and he took a picture back in October. This is Jupiter. We took a picture in October of Jupiter in infrared. By the way, the red spot and oval BA are fading very significantly in the last month. I don't know if you've ever looked at Jupiter, but apparently there's high ammonia clouds now in Jupiter's atmosphere. It's kind of covering up these features. Okay, so Freddie took this picture October 13th. 10 hours later, Antonin Gallardo in Italy took Jupiter about the same time, 10 hours later on the same date. And so Freddie had these because we all correspond and send their images to everybody. And Freddie said, that's really cool. And he made a little animation here, 10 hours. It just shows the differential cloud rotation on Jupiter in 10 hours. Isn't that cool? And it's just, easy to do. Two guys with small telescopes, and so I just thought I'd show that. But that, again, is international cooperation, which is very important. Unless, they're from the Netherlands, and then we kind of ignore it. But, other than that. Okay, we were talking about Mars' seasons, polar ice caps. They wax and wane with the season. And this just shows the North Polar Cap retreat back in 1995. These are horrible images. They were great at the time, but those were the old Lynx camera. But you can see as spring and summer progress, the cap gets smaller. And for about 40 years, we've been measuring this cap. And I've talked about this before. I'm not going to belabor it, but we've found that the polar caps tend to be smaller in the 1990s than they were in the 80s, and then those again are smaller than they were in the 60s. And this was carried on by Michael Malin with the Mars Global Surveyor spacecraft, where this kind of piqued his interest. This has been published in Icarus and the Journal of Geophysical Research. And when this first came out, it went against the grain. Everybody said, oh, Mars is always the same every apparition. The polar caps always melt the same, but we showed they didn't. And this is what the previous two speakers were talking about, kind of going outside the box and doing things of, try to get real science. We used a bifilar micrometer, which is why I had my eye surgery recently, because it's a good way to go blind. It's really a difficult technique. But we used that for many, many years, and now, of course, we're using filtered electronic images to measure this. And I will say we're among the first to coin the term global warming before it became fashionable. And this is the Mars Global Surveyor started taking pictures of the South Polar Cap, same Martian date, different years, and they found that they've extended this now up into 2007, I think. And they found that Mars is indeed undergoing some global warming, and don't know why. So could be the sun, but nobody seems to want to think that. I don't know. I'm serious. We had a woman wrote in Nature. I was in Science about a year ago about this, and she was a JPL scientist, and she said, "Well, it's warming because the dust storms have increased." Well, why have the dust storms increased? Because it's warming, you see. But we didn't kind of follow that logic. Okay, anyway, this is just of interest because I really don't have much to tell you about Mars, so I'll fill you with all this crap. North Polar Cap is mostly, it's CO2 over a water ice core. And we've long suspected this because it doesn't really go away completely in summer. So this core is very thick. And the recent spacecraft have shown that to be the case. South Polar Cap is mostly carbon dioxide. So the North Polar Cap is the main water reservoir for the Northern Hemisphere. And the South Polar Cap, the water, or the Southern Hemisphere, the water comes from Hellas and Argyre. There are two great impact basins in that hemisphere. So you get a kind of a different pattern of cloud formation and meteorology in the north versus the south. But there is water on Mars, as you can see. Unfortunately, we still don't know if it's liquid. It's for sure water vapor, and it's for sure ice. And the jury is still out whether the water is any liquid water on Mars. I won't get into that. They think they see it trickling down canyons and things, but I doubt it. The atmospheric pressure is just too low to sustain liquid water. And this is, not an artist's rendition. This is from the MOLA spacecraft laser imaging of the North Polar Cap, and you can see it's very thick, very rugged terrace terrain, and this water cap may be actually, they think, miles thick now. So there'd be a load of water there. This is a study that Jeff Bish did back going through 26,000 Mars observations over a 20-year period. And the cloud counts are much higher in the northern spring and summer, which is what we have now on Mars, than in the south. Again, because of where the water reservoirs are. Okay, enough of that. Let's go to what Mars is like this year, this apparition, 2011, 2012, and we start out March 20th, or September 13th. Mars date March 20th, which is the day before the vernal equinox. And some guy named Sean Walker took this, 4.9 arc seconds. Now this is amazing what these guys are doing. Before, with film, it got to 10 or 12 arc seconds, you might get a halfway decent picture. And with CCD cameras, up until very recently, maybe 8 arc seconds. But this is, they're getting pictures of Mars when it's just coming out from behind the sun now. And you can see the very large, not just the polar cap, this is actually a hood over the polar cap. The polar cap is covered with cloud during its own winter. And the hood is just starting to, looks like it's just starting to dissipate. And a few weeks later, yeah, we see the nice, shiny polar cap showing through. So we're into Martian spring, tra-la. And by November, which is April 21st, the Mars date, Damian Peach took these. You see the little globs on the surface that aren't polar cap. And that's, see right there in the blue filter? That's a cloud over a volcano called the Elysium Shield. And that's one of the first ones to appear during Martian early spring. This is the two shield volcanoes in the area called Elysium on Mars. And very much like in the Rocky Mountains in the spring and summer when you get warm, moist air going up the in the afternoon going up the slopes of the mountains, the air condenses to form clouds, and these are called orographic clouds. And we see that there's an abundance during the spring and summer on Mars over these great volcanoes. These are actually kind of small volcanoes, but that's generally, we first see it there. Now we're moving ahead to February this month, and Martian date is May 27th, and you're beginning to notice now the polar cap is beginning to do weird things. It's starting to break up because we're getting now into late spring on Mars, which is where we are. Again, we see another cloud forming, and this is Sean Walker again. These weren't by accident, Sean, because you talked here. I just, But will you process my images for the next month because I did this? Okay. Anyway, okay. Yeah, this is not Elysium. Elysium would be over here, and it's not real bright because the afternoon, these things brighten as the day progresses. That's another glob. So what kind of glob is that? Well, that's a glob over Olympus Mons, which is the huge volcano on Mars, 400 miles across, 17 miles high. If it were where Jacksonville, Florida is, we'd be able to see its peak from here. It's a big mother. And so clouds form over this. The reason these volcanoes on Mars are called shield volcanoes, Steve O'Meara would be much better to talk about volcanoes, but anyway, the Earth has plate tectonics, so you get a hot spot on the mantle, and it forms a volcano here, it formed one there, and it just moves on. On Mars, it just keeps, increasing the same place. You don't get the plate tectonics, and these volcanoes build in monstrous sizes. And also, the gravity is a third of what it is on Earth, so you get, that in helping out. Is that okay, Steve?
That's good.
Thank you. Okay, here's a picture I took last night of the cloud over Olympus Mons. And this is the Hubble image of a typical summer day on Mars. You notice the North Polar Cap is small, it's in the summer. And you've got these 4 huge volcanoes, Olympus Mons, Ascraeus Mons, Pavonis, and Arcia, and this is Alba Patera, which is another volcano, which this season particularly has lots of clouds on it. So this is really cool, and you can see this stuff very easily with amateur telescopes over the next couple of weeks. These clouds are only going to intensify. So this back in 2001, we had a big dust storm on Mars, and you've got these are the Arcia, Pavonis, and Ascraeus, and Olympus Mons, the peaks actually sticking through the dust. And they measured this, the dust height was less than 9 kilometers. So you can actually even measure the height of these dust storms by looking at the volcanoes sticking through. Isn't that neat? Cool. This is Arcia Mons, and this is in the southern summer. For some, again, because the water distribution is different, this one, usually the cloud over this one persists quite a bit longer. And you see here, it tends to brighten as the, see that? Isn't that cool, as afternoon progresses? Okay. Now, I'm going to take just a pause here because, Sean, if you would come over here, please. I have the wrong picture in here, Yes, we had a last minute, here, let me just hit escape. Everybody take a break. Almost done anyway.
When we miss it?
I don't know, I'm missing, we could put the one I gave you over onto the.
That was the one you gave me.
All right, go to your, let's see here. Go to the, I want to see the whole, no, I want to see the slide tray.
Oh, what?
Didn't I put another one over there? Go all the way to the end.
All the way to the end?
Yeah. Otherwise, I'll just run it off my, okay, go up. No, see this. Yeah, okay, it's okay. It's all right.
All right, see, there it is.
All right, let's go back. Thank you. I'm sorry.
Getting back to where you were.
Yes. So I had some slides in here I didn't want to,
Load
I
it
can
fresh.
just start with that one, and we're fine.
Oh.
Thank you, sir. I'm sorry. That's because I spilled my drink while you're having your talk. Okay. Okay, now, the Tharsis Bulge, which is where those great volcanoes are, and the Elysium Planitia, or plain, that's what we've been talking about, where these big volcanoes are. They've recently found that these are sources of methane gas on Mars. And the significance of this is that there are very few things which will cause methane to be in the atmosphere. And one of them is life, okay? And this has got the astronomers really kind of worked up. There are a lot of other things that will cause methane to appear in the atmosphere, one of which is Tippy. But the thing is with Mars, there's enough concentration it has to be replenished. And it's apparently been staying there for at least since they've been measuring it, which is now a couple of years. So this is kind of exciting that there may be something producing methane, and it's either, present life or decaying life, they don't know. But it's a biological signature. So that's kind of neat. Okay, so now we're back here to the what Mars is doing. And this is by May 16th, Mars date in January. See these clouds? These are over the three volcanoes plus Olympus plus Alba Patera. And these actually, we call these the domino clouds. And in another month, they're going to probably coalesce to form a big letter W on Mars. So it's called the W cloud. Isn't that neat? But you look here, if you look at this blue light image, or that's ultraviolet, right there. See how much better you see them there than you do there. This is because real men use color filters when we do this stuff. I don't use color, well, I do use color filters now. I use a monochrome camera and shoot through different colors. But we take this picture of Mars here. This is a photograph. It was taken back in 1995, I guess, or 98. This is Mars, and this is that streak I told you about. I even did it with photography, so ignore that. Okay, you got Mars here. South is up, and what do you see? You got the two polar caps, right? Anybody? Okay, wrong. That's wrong. But we don't know. We got two bright things. That's South Pole and that's North Pole. And you got a piece of snot over here. They don't know what that is. Okay, it's a little white job there. So how do we find out what that is? Well, we use color filters. I'm now going to lumber over to the projector. And let's see what happens if I use a red filter on that picture. Ooh, what happened? The south one stayed good, right? But the other two kind of went away. Aha. Okay, let's use a blue filter. And now they're all real bright. Okay, now what does that tell us? There. Okay, blue doesn't really penetrate Mars's atmosphere very well. So when you're using blue, you're really looking at atmospheric phenomena, which is clouds. So what we've got here is the south polar, we've got the south polar cap. We've got the north polar hood. You never see the polar caps of Mars at the same time. One of them is always covered with a hood. Aha. Okay, so that's cloud. And that's the Olympus Mons cloud right over on the evening limb. So we got two clouds and a polar cap, and it's very easy, and you can do that visually. And when you're looking at Mars, just get a piece of blue, whatever. Doesn't have to be anything fancy. You hold it up to your eye when you're looking at Mars. When the side of the volcanoes is around, you'll see these really nice, pretty little white clouds. Like that. This is Freddie Williams' pictures again. See beautiful cloud details, these orographic clouds. And notice too, the cap now, it's getting into late spring on Mars, and the cap is showing all these rifts and globs, and that's what it looks like from the spacecraft view, that you get big chunks of ice breaking off. These all have ancient names too. They give them, they're pretty much the same, each apparition. And then you have canyons and gullies inside the cap. Well, one of the things these canyons and gullies do, remember, this is really cold, and out here it's beautiful spring on the rest of Mars, or in the northern hemisphere. So it's only 40 below zero instead of 200 below zero. And you get a big temperature gradient. You get winds whipping down these gullies, and which probably is what carved them out to begin with. That's just another rendition of it. And you wind up then with a big surprise. Mars, I always say, is kind of like eating in a Chinese restaurant. Always got a surprise, okay? That wasn't chicken. Or perhaps eating out with Tippy. Love that expression. Okay, so this year we had a big surprise on Mars because we're seeing these rifts in the polar cap, and we're also seeing some little weird colored thing coming off to the side there. And this was really initially, attention was brought to it by Efrain Morales in Puerto Rico, who's just an avid astrophotographer. He took this picture back on February 2nd, just a couple of weeks ago. Mars date, May 26th. Again, it's getting the last month of spring. And look at that, this cap is covered with this yellow stuff. And Efren correctly said, it looks like it might be dust. And so we've been following this. This is another week later. You see this dust coming up. What we were seeing is not really rifts in the cap. We were seeing actual dust clouds being raised by the polar winds. And this is the first time, really, we've seen this in this detail, that amateurs have been able to, or professionals for that matter, have been able to image this. And here's, the other thing, this is Efren back on February 12th. Got this band across the cap. Well, you're not seeing the whole polar cap because